This lesson is part 2 of multiplying radicals, and in this lesson we're going to utilize a few things that we've learned already. So we know how to use a distributive property, we know how to FOIL using two binomials, and we also know how to use a product rule for radicals, and this is going to be important in this lesson. Now, as we go through this lesson, it's important that you do the problems as I do. Try not to skip too many steps because it does get pretty messy many times when you use the distributive property or FOIL with square roots or cube roots or fourth roots, whatever the root is. All right. It's not a difficult section. You just have to be careful with the work that you write down. So for example, the problem will say multiply. And then as always, just like you did with part 1, and remember in part 1, and just kind of remind you about part 1. So remember in part 1, when you multiply two radicals, we first of all use the product rule to write it as one radical, and then we simplified. So as with part 1, it is very important that at the end you simplify. All right, so you have to simplify the end. Okay? Okay, so let's look at number 1, and then we're going to talk about these three things. So number 1, let's suppose you had the square root of 10 times the square root of 3 minus the square root of 7. So basically you have this radical that's, and it's just one, kind of like a monomial right here, and one factor, and you're multiplying it by a binomial, right? Okay, so remember, to get rid of the parentheses, you're going to distribute, just like you would with a normal, if you had 4x times 3x minus 2, you would distribute, and this would be 4x times 3x is 12x squared, and then 4x times a negative 2 is a negative 8x. You use the same idea here. All right, now the way I would do this is I would actually write out what I'm seeing. So I know I've got to say the square root of 10 times the square root of 3. Write it out. Minus, and then the square root of 10 times the square root of 7. Okay, so if you can visually see it, if you write it out, you visually see it, and then you tend to know what else to do after that. So after that, I'm going to use the product rule now. And so the product rule says that I can rewrite this product as one square root. So I can write this as a square root of 30, right? And then minus, and then the same thing here. That will be the square root of 70. And then just like you did in part 1, you need to simplify the radicals before you say that's your final answer. So if you look at 30, besides 1, is there a perfect square that goes into 30? And the answer is no, except for 1. There is no other perfect square. For 70, besides 1, is there another perfect square that goes into 70? No, there is not. So that's your answer. Okay? That's all you do there. All right, number 2. Number 2, let's suppose we had the square root of 6 times the square root of 3 plus the square root of 2. Okay, so again, I have a monomial times a binomial, right? And so we're going to use the distributive property. And so I'm going to get the square root of 6 times the square root of 3. Write it out, just like I'm doing. Plus, and then the square root of 6 times the square root of 2. And then using the product rule for square roots or radicals, I get the square root of 6 times the square root of 3 is the square root of 18. Plus the square root of 6 times the square root of 2 is the square root of 12, right? And then we simplify. So I know I can simplify the square root of 18. So what perfect square goes into 18? And let's use the largest. So the largest would be what, 9? So that would be the square root of 9 times the square root of 2, right? And then 12, I can simplify. What perfect square goes into 12? 4. So that means I can rewrite this, again, using a product rule. So I use the product rule to go from here to here. I'm using a product rule to go from here to here. Okay? So it'll be the square root of 4 times the square root of 3. All right, now make sure you understand why this becomes this, because remember the square root of 18 can be written as the square root of 9 times 2. And then using the product rule, remember this product rule from previous lessons, this right here, that when you write it as the square root of a times b, you can write it as the product of two square roots. All right, so that's what this is. So that means I can write this as the square root of 9 times the square root of 2, and that's what that is, okay? All right, now let's simplify what we can. So I know that 9 is a perfect square, so I can simplify the square root of 9 as 3, so I get 3 square root of 2, plus, and then square root of 4 is 2, so you get 2 square root of 3. So I simplified, and now the question is, can I combine anything? So no, you cannot combine anything because this is square root of 2, this is square root of 3. Even though both the radicals have the same index, 2, the radicands are different. So that's your answer. See, it's not that bad. Just knowing things that you've learned in the past helps you with the new stuff, okay? All right, number 3, let's suppose we had this for number 3. We had the square root of 6 times 2 minus 5 square root of 6, okay? So again, I need to get rid of the parentheses. So I have this monomial times this binomial, so I'm going to use the distributive property. And so I'm going to get the square root of 6 times 2 minus the square root of 6 times 5 square root of 6, okay? And then let's talk about this one. So the square root of 6 times 2, there's not much I can do with that, but I'm just going to rewrite the 2 in front because we know that's the preferable way to write this type of radical, this type of product. And over here, let's talk about this. So you see you have the square root of 6 and the square root of 6, right? You have 3 things that are being multiplied together, 3 factors, correct? And so the order in which you multiply does not matter. But notice I do have some square roots that are multiplied. So I'm going to use the product rule to write this as 1 square root. And we'll put the factor of 5 in front. So this becomes 5 times the square root of it, and 6 times 6 is 36. Okay? And now let's see if I can simplify anything. So can I simplify this square root of 6? No, because the only perfect square that goes into 6 is 1. But I can simplify the square root of 36 because that's a perfect square. So the square root of 36 is 6. So this becomes 2 square root of 6 minus 5 times 6. And then simplify this part. 5 times 6 is 30. And so you're done. So that's 2 square root of 6 minus 30. Okay? All right. So that's number 3. Let's do number 4. All right. Number 4. Let's suppose we had this for number 4. All right, number 4, we have this, the square root of 5x times 2 square root of x plus the square root of 5. Okay? All right, so I want to multiply these radicals, in which case they're square roots. So to multiply this by this, I'm going to use a distributive property. So I get 5, and actually write it out. I get the square root of 5 times x times 2 square root of x, right? Plus the square root of 5 times x, like that. So your radicand is 5x times the square root of 5, okay? All right, now let's use the product rule with this part. So I know, you see I have 3 factors here, the square root of 5x, 2, and the square root of x. All right, so the square root of 5x times the square root of x, think about that, square root of 5x times the square root of x, right? So do y'all agree that's going to be the square root of 5 times x, which is the square root of 5x squared, okay? So I'm going to put that here. So it's going to be 2 square root of 5x squared, okay? So all I'm doing is using a product rule to write these 2 products with the square roots as 1 square root, okay? Plus, and then go here. So let's talk about this. So this is, for that one, think about this. This is the square root of 5x times the square root of 5. So using the product rule, this becomes the square root of 5x times 5, which is the square root of, and then 5 times 5 is 25. So 25x, right? So that goes here, the square root of 25x. Okay, so that's where I'm at. So make sure you understand how it went from here to here, and then from here to here. Okay, that's this work right here. Okay, now the next thing is to simplify these radicals. So now I'm going to rewrite this using the product rule again. So what I mean is this. So I'm going to rewrite this as 2 times, and then this product, the square root of the product, I'm going to write it as the product of each square root. So it'll be the square root of 5 times the square root of x squared. Okay? Plus, and the same thing here, the square root of 25 times the square root of x. So the product rule. And then I'm going to simplify. Can I simplify the square root of 5? No. But can I simplify the square root of x squared? Yes. So that's even. So that's the easy kind. So what times itself is x squared? X. So this becomes 2 square root of 5 times x plus, and then the square root of 25 is 5, so you get 5 square root of x. And we just prefer, remember, let's go ahead and rewrite this where the x is between the 2 and the square root of 5. So then your final answer would be 2x square root of 5 plus 5 square root of x. Now before we go on, let me ask you, are those like terms? Are these two terms like terms? Well, let's look at the square root first. This is square root of 5. This is square root of x. Are the radicands the same? No. So right away you say you cannot combine them. So that's your answer. Okay? All right, number 5. Okay, so in 1 through 4, to multiply this monomial times this binomial, we use distributive property. Okay? In all cases, the distributive property. Okay? But in number 5, let's suppose we had this. Let's suppose we had the square root of 7 minus the square root of 10 times the square root of 7 plus the square root of 10. How do you think you're going to multiply those out, those two binomials? Yeah, you can use the FOIL method, right? You use a FOIL. Just like you did when you multiplied two polynomials that were binomials. Okay, so remember FOIL, first, outer, inner, last. So if you look at the first, just like this. I have the square root of 7 times the square root of 7. Actually write it out. Don't do this in your head. Write it out so you can visually see it. The outer is going to be a square root of 7 times a positive square root of 10 will be a positive square root of 7 times square root of 10, right? The inner, a negative times a positive is a negative, so it'll be square root of 10 times square root of 7, okay? And then the last, a negative times a positive is a negative, and so that becomes the square root of 10 times the square root of 10, okay? So I just wrote out what I'm looking at. So first, I multiply the first two together, that's this. I multiply the outer, that's this. I multiply the inner, that's this. And I multiply the last, and that's that, okay? Now let's use the product rule to write this as 1 square root, 1 square root, 1 square root, 1 square root. So this becomes the square root of 7 times 7 is 49, plus 7 times 10 is 70, okay, minus 10 times 7 is 70, so that's square root of 70, minus, and then the square root of 10 is the square root of 100. All agree? All right. Now, let's go ahead and simplify. Can I simplify the square root of 49? Yes, 49 is a perfect square, so what's the square root of 49? 7. Okay, now, plus, can I simplify the square root of 70? No, because the only perfect square that goes into 70 is 1. So I'm going to leave this as square root of 70. Same thing here, minus square root of 70, and then minus, and then square root of 100 is 10. Now let's combine like terms. So I know definitely I can combine these. I know right away I can do that, because 7 subtract 10 is a negative 3, right? But look at the radical. Are these radicals the same? Yes, they're both square root of 70s. But here's the thing. This is a positive 1. This is a negative 1. So what happens when you add them up? You get 0. So there's your answer, negative 3. Okay? All right, so that's number 5. Okay, let's look at number 6. Number 6, we have this for number 6. We have 5 minus the square root of 7 squared. All right? So remember, when you have a binomial squared, what that means. So when you have, or a trinomial, it doesn't matter. Whatever factor you have here is being squared, that means that the square means that you're multiplying this by itself twice. That's what it means. So this becomes 5 minus the square root of 7 times 5 minus the square root of 7, right? And then let's use the FOIL method. So first, so remember your first, you'll multiply the first together and actually write it out. 5 times 5. Say it. 5 times 5. The outer, a positive times a negative is a negative. So that'll be 5 times the square root of 7 for the outer, right? The inner is going to be a negative times a positive is a negative. So be, I'm going to put the 5 in front. So it'll be 5 square root of 7. So you'll agree that square root of 7 times 5 is the same as 5 square root of 7. And then a negative times a negative is a positive, so be careful with your signs. And then I have square root of 7 times square root of 7. Okay? All right, so first, outer, inner, last. Okay, now let's simplify each of those terms. 5 times 5 is 25. Minus. I'm going to leave this as 5 square root of 7. Minus 5 square root of 7. And then this will be 7 times 7 is 49, so it will be the square root of 49. Okay? Now I'm going to simplify the radicals. So can I simplify the square root of 7? No, because the only perfect square that goes into 7 is 1. Same thing here. Can I simplify the square root of 49? Yes, that is 7. Square root of 49 is 7. So I get 25 minus 5 square root of 7 minus 5 square root of 7 plus 7, right? Okay, now we're going to combine like terms. So combine like terms. And so when I combine like terms, I know I can combine the constants. So 25 plus 7. 25 plus 7 is 32. Now look at this. So are these like terms right here? Yes, those two square roots are like terms because they both have the square root of 7. Now this is a negative 5. This is a negative 5. What's a negative 5 and a negative 5? A negative 10. So this becomes negative 10 square root of 7. So there's your answer. Okay. Now, if you wanted to put the radical first, in other words, if you want to put this first, you can. You could say negative 10 square root of 7 plus 32. Does not matter. Okay. All right. Well, that was number 6. Okay, let's do number 7. Number 7, we have the square root of 3 minus 4 square root of 2 squared. So we have another binomial being squared. Okay, so remember what that means. That means I'm going to multiply this by itself twice. So that becomes the square root of 3 minus 4 square root of 2 times itself. Okay? And so let's use the FOIL method. So I have first times first, write it out. Square root of 3 times the square root of 3. The outer, write it out. A positive times a negative is a negative. So I have the square root of 3 times 4 square root of 2. Okay? And then same thing here. Now remember, when you square a binomial, the outer and the inner will always be the same. So here's the outer and here's the inner. So the inner, I have 4 square root of 2 times the square root of 3. Notice that these two are going to be actually the same thing. Okay? Same thing like it was here. See, those are the same. And then the last, a negative times a negative is a positive. And so I have 4 square root of 2 times 4 square root of 2. Okay? All right, so it kind of looks messy, right? So that's why I said earlier, actually write this out. It does help. You can see what you're thinking. All right? Now let's use a product rule to simplify this. So the square root of 3 times the square root of 3 is the square root of 9 minus. Okay, now here you see you have 3 factors, square root of 3, 4, square root of 2. So let's multiply the square roots together. So it's going to be 4, and then square root of 3 times the square root of 2 is the square root of 6. Same thing here, square root of 2 times the square root of 3, so I have minus 4 square root of 6. And then over here, see how you have these 4 factors, 4 square root of 2, 4 square root of 2? Let's do the 4s first. 4 times 4 is 16. Times the square root of 2 times the square root of 2 is the square root of 4. Okay? Make sure you understand where I got the square root of 4. Square root of 2 times the square root of 2, square root of 4. Now let's simplify what I can. Can I simplify the square root of 9? Yes. Square root of 9 is 3. Minus. Can I simplify the square root of 6? No. So I'm going to rewrite it. Same thing here. Rewrite it. Plus 16. Can I simplify the square root of 4? Yes. It's 2. All right, so let's see what I have. So I know I can work with this. So I'm going to have 3 minus 4 square root of 6 minus 4 square root of 6 plus, and then 16 times 2 is 32. Okay, now just like we did over here, we're going to combine like terms. So I have these 4 terms here. I know that these are alike, right? Because 3 plus 32 is 35. I also know that these are like terms right here, because they both contain the square root of 6. So what's a negative 4 square root of 6 and a negative 4 square root of 6? Negative 8 square root of 6. Negative 4 and negative 4 is a negative 8. And so there's your answer. Okay, so that's number 7. Okay, let's look at number 8. So number 8, we have this problem, number 8. All right, so number 8, we have 5 square root of 3 plus 2 times the square root of 3 minus 1. So 5 square root of 3 plus 2 times the square root of 3 minus 1. So I'm going to have two binomials, so I'm going to use the FOIL method. So first times first, and actually write it out. Say 5 square root of 3 times square root of 3. The outer, a positive times a negative is a negative. So I have 5 square root of 3 times 1. The inner, positive times a positive is a positive. 2 square root of 3, right? And then the last, a positive times a negative is a negative, and then 2 times 1 is 2. So 2 times 1, right? Okay, so notice I wrote it out. First times first. So first times first. The outer, so those two terms right here. The inner, 2 square root of 3, that's this. And then the last, positive 2 times negative 1 is this, okay? All right, let's simplify what we can using what we know. So I know that to multiply these three factors together, I'm going to use the product rule with these two square roots. So that becomes the square root of 5 times the square root of 3 times 3 is 9, minus 5 square root of 3 times 1 is 5 square root of 3, plus, and then this is still 2 square root of 3, minus, and then 2 times 1 is 2, okay? Now I'm going to simplify what I can. I know I can simplify the square root of 9, because the square root of 9 is 3. 9 is a perfect square. So 5 times 3 minus, I cannot simplify the square root of 3. Cannot simplify the square root of 3. So I'm just going to rewrite these two terms. So 5 square root of 3 plus 2 square root of 3 minus 2. And then 5 times 3 is 15, right? Then we rewrite everything else over. So notice I'm doing one thing at a time. Try not to rush things. Just do one thing at a time. Be careful as you go through this. And so now let's combine like terms. So I simplified everything I can at this point. So now let's see if I have any like terms. I can combine these constants. So 15 and a negative 2 is 13. I can combine these square roots because they both contain square root of 3. The radicands are the same. So what's a negative 5 square root of 3's and a positive 2 square root of 3's? What's a negative 5 plus 2? A negative 3. So I have negative 3 square root of 3. And so that's your answer. Okay? Number 9. Number 9, let's suppose we have this for number 9. Square root of x plus square root of 5 times square root of x minus square root of 3. Okay? Okay, so let's use the FOIL method. So I have first times first. So I have the square root of x times the square root of x. The outer, a positive times a negative is a negative. So I have the square root of x times the square root of 3, right? This times this. Okay. The inner, positive times positive is positive. Square root of 5 times square root of x. And then the last, and positive times a negative is a negative. Square root of 5, square root of 3. Okay? All right, let's multiply with what I can. So square root of x times square root of x using the product rule is the square root of x squared. Minus, using a product rule here, x times 3 is 3x. So that's the square root of 3x. Here, 5 times x, so that'll be the square root of 5x. And then here, that's minus 5 times 3 is 15. Okay? Now, can I simplify anything? I have 4 terms here. Can I simplify the square root of 15? No, because the only perfect square that goes in 15 is 1. Can I simplify the square root of 5x? No, because the square root of 5 I cannot simplify. And the exponent of x is less than 2, so I cannot simplify that. Same thing here. But can I simplify the square root of x squared? Yes, because what times itself is x squared? X. So I have x minus square root of 3x plus square root of 5x. Square root of 5x, and then minus square root of 15. And notice, none of these are like terms, right? These are like terms right here. Because that's the radicand here is 3x, the radicand here is 5x. The radicands are different, so you cannot combine them. So that's your answer. Okay? All right. And let's do one more, just to do a little bit, just do another problem. So this will be number 10. So one more, number 10. So we have the square root of 7 plus the square root of 5 times the square root of 2 minus the square root of 5. Okay? All right, so again, fall method. Square root of 7 times square root of 2. Write it out. Square root of 7, square root of 2. First times first. Outer. A positive times a negative is a negative. Square root of 7 times square root of 5. Write it out. Show it. Inner. A positive times a positive is a positive. Square root of 5 times square root of 2. Write it out. And then a positive times a negative, so the last, a positive times a negative is a negative, and so I get the square root of 5 times square root of 5. Write it out. So notice all I did was I did first, outer, inner, last. So now I'm going to use a product rule. The square root of 7 to the square root of 2, I can write it as 1 square root, so it'll be square root of 14. This right here, square root of 7, square root of 5, using the product rule, that's be the square root of 35. Plus square root of 5 times square root of 2, square root of 10. Minus square root of 5 times square root of 5 would be the square root of 25. Okay? Now I have these 4 terms. Can I simplify any of them? Can I simplify the square root of 14? No. The only perfect square that goes into 14 is 1. Can I simplify the square root of 35? No. The only perfect square that goes into 35 is 1. Same thing here. But can I simplify the square root of 25? Yes. And you want to do it. Don't leave it at square root of 25. You're not going to get full credit. Because remember, you got to simplify. And so that's going to be 5. And so I get square root of 14 minus square root of 35 plus the square root of 10 minus 5. And notice none of these are like terms. The radicands here are different, and this doesn't even have a square root in it. So that is your answer. Okay? So in this lesson, to multiply radicals, we had to utilize the distributive property, the fall method, and the product rule. Okay? All right, so that should take care, that should give you enough information to understand how to multiply radicals that look like these, where you have monomial times a binomial, or when you have 2 binomials, as we did with something like number 5. Okay? All right, so that's the end of this lesson.